Hi friends, welcome to this chemistry session. In the previous video, we saw the postulates of VSERP theory. In this video, we are going to deal with the determine the shapes of molecules using VSERP theory. So basically there are two types of molecules we can observe. One molecule are those which are having lone pair of electrons. The other one is the molecules which don't have lone pair of electrons. Basically today we are going to see the molecules which don't have lone pair of electrons. In the next video we are going to see the molecules which are having lone pair of electrons. Okay, so the first type which don't have lone pair of electrons, there are only we have electron pairs which are bonded pairs. There is no lone pair. Okay, so the first one is if electron pair are 2. If the electron pair are 2, then we see the molecules will be having a linear structure. Let us consider A be a central atom and this be the bonded pair and these be the atoms attached to the central atom, and the electrons are arranged in this fashion. Okay, so if you look at the molecular arrangement, it may be like this. B be the atoms which are linked to A, and this is a linear. This structure is called as linear structure. For example, we see beryllium chloride or mercury chloride. So these are the two examples we can observe in this linear structure. Okay, if there are two lone electron pairs, if the electron pair is 3, then we see that this is the central atom and we have bonded pair here, and these are the electrons. When I do the molecular structure, it looks in this fashion. If you closely observe, these 3 atoms, B atoms, lie on the same plane with A. So we can say that all 3 atoms of B all are coplanar with A. So we can say this is a planar molecule, and you can see that it is a the atoms are arranged at the corners of equilateral triangle. So we can say it as a trigonal planar. The molecule will be having a geometry trigonal planar. And for example, we can take BF3, boron trifluoride, where boron is the central atom and fluorine is attached to it. If the electron pairs are 4 in number, how I am telling the electron pairs is, this is 1 electron pair, this is 2 electron pair, this is the second electron. There are 2 electron pairs, right? Here 1, 2, 3 electron pairs. Now I have 4 electron pairs. Okay, so it will be arranged in this fashion: 1, 2, 3, and this is 4. You can observe that I could have written it in this way also. Just an assumption. If it is A and these are the electron pairs, I would have drawn, and all may be in the same plane, all may be making 90 degrees with each other. Okay, but there will be repulsion between these bonded pairs. We know in valence electron pair repulsion theory that these bonded pairs and electron pairs, they orient in such a way that in order to reduce the electronic repulsion. Hence, rather than forming 90 degrees, they form 109.5 degree. Okay, so here we see the angle is, bond angle is 120 degree. Here it is 180 degree. Okay, so this structure looks in this way. This is molecule atom B, this is atom B, and this is atom B. So when you just join this, you get a tetrahedral structure. Tetrahedral means tetra, 4. Hedra means faces. If you closely look at this molecule, this will be the first surface, the second, the backside will be third, and down, that will be the fourth. 1, 2, 3, and the base what we are seeing, that is the fourth phase. So we say it as a tetrahedral. For example, I will give ammonium ion, or the very famous example methane. So these are the example for tetrahedral structure. If there are 5 electron pairs, if they are 5 in number, then I will get geometry in this way. This will be the central atom. I am going to see a trigonal planar structure here, and 3 electron pairs at the corners of equilateral triangle, and I am going to see 2 structures which are perpendicular to this equilateral triangle. So it will be in this way, and this makes 90 degree. Okay, so here are 2 atoms, 1, 2, 3, 4, 5 atoms. So when I do the geometry of this using the atoms, this is the first and this is the second, and 3 atoms are lying in same plane with the central atom. So if you closely look at this is a trigonal structure, and above it, above this plane, I am having a pyramid. Below this, again I have a pyramid. So we can say that trigonal bipyramidal, trigonal, because it has a trigonal planar structure. Again I have a pyramid above and below, so you can say trigonal bipyramidal. Example for this: PCl5, phosphorus pentachloride, or BF5, boron pentafluoride. So these are the molecular geometry for the electron pairs which are 5 number. Now it is the 6. This is the last one. So if there are 6 electron pairs, here is the central atom. Let me draw a square planar structure here. 1, 2, 3, 4. Now I have still 2 electron pairs. Already 4 have been done. So I have 2. This is the 5th. This will be the 6th. And it will be in this way. So in this atomic structure, in the molecular geometry, I am going to get in this way. So just let me just rub it off so that I can get more space to draw the 6th structure. Okay, so this is the structure I am going to draw here. This is the central atom, and this is the square planar structure. This is the atoms linked to the central atom. This is the 4th atom, and they are coplanar with the central atom. Now I have 2 atoms still. Okay, this is the 5th atom, and this will be the 6th. This is going to be the structure which I am going to get. If you see this, you're going to see that there is a square planar. Above that you have a pyramid. Below that again there is a pyramid. The molecular geometry says it is octahedral. Octahedral. Why is it called octahedral? Because octa means 8, hedral means faces. So if you closely observe this structure, you're going to see that the behind portion with the first one, this side with the second one, again I have this side and even this side too. So there are 4 faces at the top, and below this square planar again there are the 4 faces. So 4 plus 4, there are 8 faces. So it is called octahedral. For example, I have SF6, sulfur hexafluoride. So this is the example for the 6 electron pair structure. So these are the molecules which don't have lone pair of electrons. I have said that there is another type of molecules which have lone pair of electrons. We will discuss it in the next video. So these are the molecules which don't have lone pair of electrons. Only these have the electron pairs. Okay, these are the electron pairs. Lone pairs are those electrons which are present on single atom. Okay, so those are called the lone pairs. But here we have the bonded pairs. Here these all are bonded pairs because those electrons are shared between these two atoms. But the lone pairs are those which are carried by single atom. If I have an atom like this, if I have water, then these lone pairs, these electrons are present on only on hydrogen, oxygen, which are not present between this oxygen and hydrogen. These are the bonded pairs, and this is the lone pair. Lone pair are those which are present on single atom, and they should be in pairs. So those are called as lone pair. See, those molecules which are having lone pair of electrons will be discussed in the next video. Till then, take care and have a nice day. Thank you for watching.